My name is Ashley Kolb, and I'm an elementary science curriculum specialist for the Houston Independent School District. I'm very excited to be back with you again this week to do a 3rd through 5th grade lesson about soils. Our objective for today is to investigate and compare a variety of soils by their ability to retain water. Here are the things that you're going to need to do this investigation. First, you need something to write with for our data. So it could be a pencil, pen, marker, whatever you have. You're going to need something to write on, whether it be a science notebook or just a blank sheet of paper that you can use. You're also going to need to have some soil from outside, so I dug this up around near my house. You're also going to need measuring tools, so I have a 4th cup measuring cup from my kitchen. I also have, to measure milliliters later, some of these little medicine cups that you get with little medicines that you buy from the drugstore, or one of these that you get with baby medicines. You're also going to need a cup that has holes punched in the bottom of it. So I did this with a push pin in the bottom of a plastic cup. You could do it with a paper cup. You also need another cup without holes. It's nice if it's a clear cup, but it doesn't have to be. But this cup is going to hold water later, so you want to make sure it doesn't have holes. So I'm going to start with an activity to help you think about what we're going to do today. So I have a story today that was created by Miss Gutierrez and Miss Latoni, which are 2 of our HISD employees. And the story that they wrote is called Daisy the Seed Goes House Hunting. Once upon a time, there was a seed called Daisy. Daisy was very sad and crying because she didn't have a house to grow in. Earthy the worm saw her crying and came to comfort her. "Why are you crying?" he asked. Between sobs, she explained, "I need a nice environment to grow in, but I'm not sure where to find it. There are so many places that I don't know which one to choose." Earthy, her friend, who's a very clever worm, said, "Hop on my back and let's go house hunting. I think I can help you because I've tried many different environments where I can live and get all what I need too. I'm a very experienced worm." They packed their stuff and started their journey. Not long after they left, they saw in the distance a big pile of gravel next to a construction site. Daisy screamed. "Stop, this looks like the perfect place." Earthy looked at the gravel thoughtfully and said, "I don't think so." Daisy curiously asked, "Why?" Earthy said, "This is what humans call gravel. This type of soil is hard because it is made of crushed stones. It is coarse. It won't retain water even if it's found in streams and beaches. You won't be able to build strong roots and get enough water or nutrients to survive." Sadly, Daisy nodded and said, "Okay, let's keep looking." Okay, so in this part, we talked about gravel. And we also talked about, we heard the word retain, and those are 2 words that we're going to need and use later. Wiggling and wiggling, they continued their journey hunting for a house. As they were going, Earthy had a bright idea. "Let's get close to the river. We might find a good place there." He barely finished his phrase when Daisy had her eyes trapped on a beautiful reddish patch next to the road. She exclaimed, "This is it! This is so beautiful with all of its palettes of reddish and brown colors. I can't wait to build my house and start growing here." Looking at Daisy with big, wide open eyes, the worm said, "I don't think so." Looking unhappy, Daisy said, "But why not? This looks beautiful. I would like to grow up here." Earthy, with a wise tone of voice, responded, "You would be suffocated or asphyxiated because this is clay. Clay has small particles and small spaces between them. It tends to stick together, causing water to fill up the air spaces. When wet, it turns slippery and sticky, but when it dries, it becomes very hard and compact. There is no way you can grow here." So we've got our new word, clay. As they were approaching the river, Daisy's eyes opened bigger than a plate, saying, "Look, look, those kids are having a great time. Can we please get close? I am tired and bored." Daisy and Earthy were just in front of a sandbox in the park. Daisy loved the idea of growing up there. She would be in a nice wooden box, and kids will visit her frequently. She looked back at Earthy, who said, "I don't think so. This is sand, and sand feels rough and water passes through it easily. It does not retain moisture. Your roots will not be stable because its particles are loose, and you won't grow. You'll die of thirst." Earthy kept on wiggling with Daisy on his back. They were tired, so they stopped by the river to drink some water. Suddenly, Daisy noticed some pebbles. "Hey, Earthy, don't you think this is the perfect place for me? I could build my house within the pebbles that are close to the river." Earthy, looking at Daisy with a frustrated face, said, "I don't think so. Pebbles are little stones. They are the big cousins of gravel. They are rocks and they'll stop your roots from growing. They are smooth and they don't retain water." Again, with a sad face, Daisy said, "Okay, let's keep going." We learned about pebbles. Poor Earthy was exhausted. Looking for the shade of a tree, he said, "Let's rest under this tree for a little while." Looking around him, he asked Daisy, "Hey, Daisy, do you like this place?" And Daisy responded, "I do like this place. The tree is beautiful. It's next to the river." Earthy interrupted her, saying, "This is humus, the perfect type of soil for you to grow in. Humus is made of dead plants and decaying ant materials. My droppings also contribute to the nutrients of the soil. It retains water and provides oxygen." So we learned humus. And another word back here that we'll talk about later is the word decaying. Daisy gladly accepted, and her friend dug into the humus, making a hole for Daisy to get in. At last, they were both in the best place to grow. The end. Okay, so over here, I've built a cognitive content dictionary, and we're going to talk about, and throughout this lesson, we're going to learn about one of the words from this story. So we're going to talk about all these different kinds of soil and do an investigation with them later. But I want you to think during the next part of the lesson on this word retain. So something that retains. Thinking about that, have you heard the word retain before? You know, I've heard the word retain before. And when I've heard it, I think about, I don't know, maybe you've heard that somebody was retained in school or somebody is retaining an object. So I'm going to put my prediction for the word retain is to hold back. So like if you get retained in school, that means you get held back, right? Or if you're retaining something for later, you're holding it back. So that's what we're going to leave now for our prediction. When we get into our investigation, we'll learn more about the word retain and how it applies to our soils and science. And we'll come back at the end and look for a definition and an oral sentence for this word. So I'll see you in just a little bit. So this is the do it part of our investigation, and this part is my favorite part because it's where we actually get to look at some materials and do something with them to find an answer to a question. So I don't know where he is, but I have someone helping me again today that you may remember from last week. Oh, there you are. Hey Maxwell, can you say hi?
Hi.
Hi. So So Maxwell is back this week to help us out as we investigate our soils. So you see a bunch of different things on this table, and we're going to talk about the different things that we see on our table. So before we talk about each one of them, we're going to start building our data chart, and we're going to talk about them one by one. So what our investigation is titled is water in, I'm getting all color creative today, water in soils. So we're going to talk about what happens whenever we put water in different soils. As I'm building my chart up here, I want you guys to be building your chart on your sheet of paper or your science notebook. So our first column that we have is for soil, because we want to know the different kinds of soil that we're working with. So I'm going to draw this line all the way across. And when I said 3 earlier, there are 3 different things that we want to know about our soil. So I'm going to make 3 lines down here to give us our 4 columns. Okay, so the first thing I want to know about my soil is we're going to add some water to them and see what happens. So I need to know how much water I'm adding to each soil. So I'm going to put volume of water added. What that means is how much water am I putting in each one. This column here we're going to call volume of water in bottom cup. And that's going to make more sense in just a minute or two. But whenever we put some water in, you see how we've got our cup in our cup here? Some of the water is going to stay in the top cup. Some of the water is going to go down to the bottom cup. So then last, we're going to want to know the difference between these two. We're going to want to know how much we added, how much is in the bottom. We also want to know how much stays in there. So to figure out how much water we still have in our soil, we're going to put water in soil, and we're going to have to do a little bit of math today with our science. So the math we're going to do is we're going to take the water added column, and we're going to subtract how much water is in the bottom. And that number that we get is going to be the number that goes in this column. You may remember these soils from our story earlier. So what we're going to do now is we're going to test what happens whenever we put water into each of these soils. So I brought some water here. This is just some water from my sink. And I have a 4th cup measuring cup from my kitchen. So what we're going to do is we're going to pour a 4th cup of water. And in milliliters, since we're talking about volume, a 4th cup of water is equal to 60 milliliters of water. So we're going to put 60 milliliters of water in each of these cups. We've got the same amount. It's about half a cup of soil in each. We're putting a 4th cup or 60 milliliters of water in each of them. And they each have a stick that in a minute Maxwell's going to help me stir around a little bit, okay? So I'm going to write 60 milliliters next to each of these because we're putting the same amount of water in each of these. In our humus.
The sand looks like it's, the sand is feeling like quicksand now.
Like quicksand? Okay, so we're gonna mix all of these up a little bit, get that water really in there so it's not just sitting at the top. And what I didn't mention here, what I probably mentioned at the beginning of the video, is that these cups have holes in the bottom so that water can get through. And we're gonna see how much water can get through each of these. So we're gonna keep stirring them a little bit, let that water really settle in there. Okay, we're gonna do the same here with our gravel. Really let the water settle in there.
It's hard to do it with the clay.
Why do you think it's hard to do it with the clay, Max?
Because it's all bunched up together.
It's all bunched up. I'm gonna break my clay apart. Use some muscle in there and get that clay to separate. That clay with my stick is starting to feel really clumpy and really sticky. Just clumpy, sticky clay. So I'm gonna let each of these work. What I'm gonna do is I'm going to set a timer for 10 minutes, and Maxwell and I are gonna leave these here and come back in 10 minutes and show you guys what they look like. So we'll be back. Okay, whoa, welcome back. So it has been 10 minutes, and I wanna show you what's going on this table over here. So we have our clay, our gravel, our sand, our humus, and our pebbles. And down here, it's a little hard to see because the cups are frosted, but if you look really close, you can see that the amount of water in the bottom of each of these cups is different. So Maxwell, which cup do you think has the most water in the bottom?
The pebbles.
So he thinks the pebbles have the most water in the bottom. And Maxwell, which one do you think has the least?
The clay.
I'm going to use some measuring tools that you may have around your house. Now, if we were in the science lab, you would be using things like graduated cylinders, moving back over here. So you would be using things like graduated cylinders, or you may be using a beaker. But here at home, I don't have those things at my house. And I don't know if you have them in your house, you can use them, but I'm gonna use some materials that I have at my house. And so I have little kids. And so sometimes whenever they get medicine from the doctor, it comes in these little medicine measuring cups like this. Or here's another one that I got from another medicine. So these medicine measuring cups, if you look at them, they usually have millimeter or milliliter markings on them. So this one has a 15 and a 30 milliliter mark. I'll bring them closer so you can see. So this one here, if you can see, that says 15 milliliters and 30 milliliters. This one here says 10 and 5. And then I have this one here that I'm going to use for my more precise measurements. This is the one they give you for like little baby medicines, but you see how it tells me every milliliter mark from 1 to 5, and it's got some tenths in between there for me. So I'm going to use these to help me measure. So Maxwell, we're going to gently take these cups off and put them on the table. And it might get a little messy, so make sure that you're doing this somewhere where you have towels or something to help you clean up. So we're going to take these off. Okay, and we're just going to look at our cups. I'm going to leave them here so I know which one goes with which. So I'm going to take one of my water cups. I'm going to measure how much was in there, and I'll come back here to do this. So I'm going to measure how much was in here using my medicine cups. So I'm going to take this cup here that has the 5 and the 10 mark, and I'm just going to pour my water in there. So I'm going to come show you what this looks like. So see how it is higher than 5, but less than 10. So here's how we're going to measure that. I'm going to put it right here. I'm going to, if I didn't have anything, I'd say it's really close to 10. You could write 10 or really close to 10. I'm going to use this medicine dropper to count by 5 milliliters. So I'm going to pull out 5 milliliters. So see, there's 5 milliliters of water in there. And I'm going to put it back in the cup. So I've got 5. Keep that number, Max, 5, okay? 5. Now I'm gonna do it again, and I have to tilt it so I'm getting all of it out of there. And I'm gonna do it again. And there's some sediments at the bottom, some of our sand that fell through, which is okay, or not sand, sorry, that's clay. Some of our clay pieces fell through, that's okay. But when I look at this, I've got it upside down so you can see, but see how it is almost to 3, but not quite. We're gonna estimate, we're gonna use whole numbers here. So we're gonna write which one it's closest to. So it's closest to 3, so I'm gonna use 3. So Maxwell, what was that number you were holding on to? 5, right? And I just added 3 to it. So Maxwell, what's 5 plus 3?
8.
8, very good. So I'm gonna write here 8 milliliters. And I got that because when I measured, there were 8 milliliters of water in that cup. Now for time, I'm not gonna have you guys watch me measure each of these, but we're gonna come back in a minute and you're gonna see this filled all the way in with the other volumes. And I'm gonna use the same method of measuring the water in the cup, using my tools for measuring milliliters that I have at home, my medicine cup, and this. You wanna make sure that you clean the sediments out of the bottom of the cup each time so that you're starting from 0 milliliters. So we'll be back and we'll show you what the rest of this board looks like. So Maxwell, when you looked at these with your eyes, you said that which one had the most water in the bottom?
The pebble.
The pebble. So look at our numbers here. Is 47 our greatest number up here?
Mm-hmm.
All right, so your eyes were pretty good with that one. You said that clay had the least amount of water in the bottom. So we had 8 milliliters for clay. So Maxwell, is clay the one that had the least amount of water in the bottom? Is that our smallest or lowest number?
Mm-hmm.
Yep. All right. So Maxwell, you made some pretty good eyeball predictions. So to fill in this last part of our chart, we have to do some math. So we want to know how much water stayed in each soil. How much water did each soil hold onto in that cup? So we have to do some math. We're going to take 60 milliliters because that's how much water goes in this measuring cup and that's how much we put in there. And we're going to subtract how much water we found at the bottom, and that's what's going to tell us how much water is still sitting in each soil. So the water that's in the soil. So if I do my math here really quick, I have 60 milliliters minus 8 milliliters. 60 minus 8, if I go back from 68, I get 52 milliliters, right? So I'm going to do that math on each of them. So these are my important numbers here. How much water stayed in the soil. So I've got 52, 24, 39, 48, and 13. So this is how much water is still sitting in each of these soils. So Maxwell, looking at these numbers that I put a box around, which soil still has the most water in it? Looking at these numbers, which soil would have the most water inside? Which of these numbers is the greatest? Clay. So 52 is our greatest number here. Very good, Max. We're flexing those kindergarten math skills, huh? Looking at greatest numbers.
I think it has 52 left in there because it didn't let that much water come through. So I think that's why it has a lot of it.
Yeah, and you know what? I think that's very true. You have the more water that's in the soil, the less that comes out of the bottom, right? So we have a science word that we use for that. And in the next part, we're going to talk about what happened with these soils. We're going to talk about that science word we use. Before we move on to that next part, there's something that you should try at home either now or you could try it at the end of this video. I left one space down here. So Maxwell, can I write right here? I'm putting my soil. And for my soil, what I want you guys to do after this lesson is over, or now before we transition to the next part, if you're watching this somewhere where you can pause, if you're watching it on TV, wait till this is over. But here, you're gonna test the soil in your yard, and you're gonna get a cup like this, and you're gonna see how your soil matches up with all of the ones that Maxwell and I did with you today. So we're gonna get into explaining what happened here. We're gonna come back and use some science words to explain the data that we found. And so we'll see you back in a little bit. Our objective today was to investigate and compare a variety of soils by their ability to retain water. So let's review very quickly the types of soil that we learned about today. We talked about gravel and how it's made from broken and crushed rock. The pieces are large, they're coarse and rough, and people use it for driveways and walking paths. We talked about clay, which is what a lot of us will find in our yards if we live in Houston. So they're small particles with little space between, they're sticky and slippery when wet, they're hard and compact when dry. People use it to make pottery, and they're reddish brown to brown in color. Pebbles are larger pieces of rock that they're larger than gravel. They have a smoother texture. Sand is very tiny pieces of weathered rock that has rough and loose particles. And our humus is made of decaying plants and organic matter, so kind of dead plants and different things like that. It's dark in color and it has many nutrients for plants. So talking about soil and water retention, there's our word retention and retain. When a soil holds in water and does not allow it to pass through, that means the soil can retain water well. When a soil allows a lot of water to pass through, it means it does not retain water well. So if we look at this picture, it's similar to what happened in our investigation. In this example, you see that the clay pot retains the most water while the gravel retains the least water. So don't let the amount of water at the bottom confuse you. So this one doesn't have pebbles like ours did. This one has silt, so it's a little bit different. But if you look at these at the bottom, clay retained the most because there's not a lot in the bottom of this pan, and gravel retained the least because there is a lot of water. When we're talking about retain, it's what's left in the pot with the soil or in the cup with the soil in our investigation. So which of our soils are best for plants? So soil can retain water and support plant growth. The best kind of soil for plants allows water to move through it slowly enough so some of it stays in the soil for plants to use. So soils that retain water are clay or humus and the soil that you probably will investigate later around your home. Soils that do not retain water well are sand, pebbles, and gravel. Those are the ones that we saw a lot of water left at the bottom. So now we're going to dig back into our investigation data and we're going to take a look at our cognitive content dictionary. Now that we've learned what retain means, and we've talked a little bit more about the science behind what happened with our soils, let's come back to our cognitive content dictionary. So we put the word retain in there earlier. We said retain means to hold back or to hold on to something. So the definition we're going to use for science that you can write down is that retain means to hold water in. We're talking specifically about water when we talk about retain. And our oral sentence that we can use, you can think of your own. Here's the oral sentence I came up with. Soils can retain water. Now, what I'm going to leave you with today is I want you to look back at our information. And after our explain, what I did was I circled clay and I circled pebbles. And so why do you think I circled them? Well, I circled clay because this is what had the most water left in the soil, and pebbles because this is what was the least water left in the soil. So I'm going to leave you with this data. I'm going to leave you with this sentence here, and I want you to see if you can fill this in. Blank retained the most or least water because blank. So this is going to be your reflection in your notebook for what we did today. I'm Ashley Kolb. I'm so glad I could join you today. Have a fantastic day of learning, and I'll see you next time. Have a great week.